Right. Hello, everyone. This is my talk, Shift Left Kotlin, thoughts and feedback. A bit about myself. So hi, I'm Albert Latacz. I am part of the Clockwork, which is a network of independent consultants. We just launched. Look us up. Also a great fan of HTTP4K. I contribute to Toolbox, which is a set of tools to get your projects up and running and generate some Kotlin for you, as well as I love Kotlin. Right, how many of you, quick show of hands, how many of you know what shift left testing is? 3, 4, okay, fair amount. Good, good. Well, according to Wikipedia, that's what it means. So it's, for those who don't know, an approach in software testing and system testing in which a testing is performed earlier in the life cycle, so it's a shift to your left. Now, that's been around for a while, and personally, I'm struck why it's not more adopted, so hence here we are. So over the course of the previous projects, in about 6 years, I've been writing in Kotlin, been following this, and it's proven to be quite successful, quite good way to set up projects, and quite a good way to have them testable. So if you think about testing of your applications normally, now I know people will argue about the shape of that pyramid and the names on them. So we can have that chat later. But generally, you have smaller units of the application being tested with your unit tests. And let's say you have multiple systems connecting together. You want some sort of an acceptance or integration test for that, right? So generally, system testing boundary is your integration end-to-end acceptance tests, right? That's all good. So we've got a few options how you test those, right? So normally, I mean, in some cases, you would go directly to your AWS, right? You would deploy your application, you would have your application deployed onto the dev environment. You would then write your test against the AWS, write your test against whatever the cloud you're dealing with, and whatever the systems are deployed into that cloud, and have those tests run. The problem with that is pretty slow. It can get pretty slow because you have networks, you have other things in a way. Also, really hard to generate failure scenarios for those tests. So if you're looking at testing a failure scenario for your S3, for example, that is super hard, right? So even though those people who said they're not doing shift left testing, I can tell you right now that when you're spinning up a Docker containers, you sort of are doing something like local stack. You sort of are doing a flavor of that, right? So you would come on, you would spin up your containers locally. That's all fine. You can start testing your stuff locally. And there's a third option. What you can use third-party fakes. And this is what I think it makes immense difference in terms of how we test software, how quick it gets, and what failure scenarios you can generate from that. So those two are shift left. We're going to focus on this for a while, because that's the only, that's just a part of it. But yeah, we're going to focus on that for a while. Obviously, you want to make sure when you're doing that, when you having your entire system wired together, running against the third-party fakes, you want to make sure they're contract tested with the third-party systems, right? This is basically the setup. How we would go about making sure that the third-party fake is in line with the third-party system. Now I really need to rush this. Now this is just looking at the time, but if you want to do shift testing better, now I'm not telling you just yet what technologies, but if you want to do shift left testing better, design for these things in mind. Design for for testability in mind. Hexagonal architecture helps with that. Make more aspects of software testable. So you're dealing with logs. You're dealing with your observability, so your events to your systems, right? Test those as well. Test all systems together, without network, run in memory possible. All these things can make your test faster. And, if your technology you're using right now can do that, that is great. What I found is HTTP4K and HTTP4K Connect, which is a set of libraries, for using connect pattern to such as AWS or Llama can help with that immensely. So if you're into if you think this is valuable, go and check that out. I'm also sending you, because there's only 15 minutes, I'm also sending you to explore the testing hyperprimith and Kotlin HTTP4K. Where is David? There he is. So yeah, talk to that guy. He done the talk on that. He will tell you more about that. But I think over the projects, what we also realize is that testing is one aspect of it, right? So testing of testing of your system is one thing, but what else? What else can you move? So Wikipedia doesn't have a definition. This is my words. These are my words. So shift left engineering, you do the same, but for every aspect of your process. And so, what can we shift left? Well, give you some examples because I can't fit all that in. Frank here will be talking about this more. Sorry. Feels like I'm referring to other people. But anyway, Frank here will be talking about this more. What we've done in previous project will work really well is enforcing of your architecture and your conventions on top of your mono-repositories, on top of your Kotlin. What it means, you can check things like, are your classes being in a certain packages? Are your classes in, you will talk about. One of the examples that I think it's sort of a convention is we have so-called code reminders. So if, for example, you have the feature flags in your code and you want to remove your feature flags after a certain time, you can put a comment on your code and that will blow up in test. So you can enforce things like that. So if you're looking for sort of a nice way of shifting feedback to the workstations, to telling people, look, this is what you need to do at a certain time, or this is the things you want to do earlier. That's Arch Unit or Consist could be a good tool for that. What else? Well, we generate documentation. Sorry, we generate the pipeline and deployment. So one of the things that we've done on I think it's 3 projects now is we have and Gradle. I mean, I know people. Some people are really like, oh, Gradle is bad. Gradle is bad. Bear with me. Gradle has really good plugin support. So you can, in your mono-repository, in your code base, put a plugin in so that you can do things like that. So that you can generate your GitHub actions for every service that you have in that repository. So you can generate other things from it, like documentation. You can generate system diagrams. You can generate dependency diagrams. You can generate your build overview. That all that you can do just by using a Gradle and Kotlin. Yeah. So I urge you to explore some of those and some of those concepts and have a look. There is a repository about that. If you go there, you can have a look how this is all set up. And yeah, sorry, that's been rushed, but there you go. Now, any questions, anyone? Yes.
That was excellent, by the way. Thank you. Do you find that the cloudy things are kind of pushing a little bit against towards shifting left? I know you mentioned local stack. Is that you trust it, or does it invert your pyramid in any way, or do you find it that you have to do more and more? You just can't do it all. The only truth is like once it goes.
Yeah. So I think there are aspects in, for example, you wouldn't duplicate your entire database. There are aspects you can shift over to your left. If, for example, you have the entire, I'm assuming you have more than one service in your system, right? Yeah. So if your services talk APIs and your services use things that are not, let's say, running for on Kafka or things, although I've done this before on Kafka as well, but if they're not very complex, this is a prime example you could do shift left. There are certain things you find hard, or you find reproducing them harder, but just to give you a concrete example, we had 4 vendors, I think, in the right place. We contract tested them, have fakes for each one of the vendors. They were all talking over API, shifted those into the tests, and tests were super fast. We're talking about, and also, more importantly, those contract tests told the vendors, because they weren't very reliable, that, hey, your system doesn't work. Because, hey, now suddenly our system, our contract test fails, and your system isn't up. Should you be worried about that? So you get certain places where you can test. This is, I think, in my experience, is a perfect fit for when you have an API test. When you would normally use your pack, for example, having contract tests, having fakes is better for those. Any?
Thanks for the discussion. And my question is very simple. So why do you endeavor to change something that when it's working? For example, documentation, some certain style guides. Why do you need to make the change? Because if it's working already, you come in, you can't change because the team would be strongly against it. It will only work for the new thing that when you start. Or, for example, if you are like a serial developer, you're trying to kickstart the projects, but this is not very often happens in real life.
Okay, so if I get that right, so the question is, why would you change? What would, for example, generating documentation give you more, and why would you change towards that?
You're trying to come in, you're trying to spend time, not building features, but doing something that is.
Yeah. So okay. So just to give you an example, if we had 20, let's say, for generating of the services, I come back to documentation. For generating of this of the built pipelines and deployments, we had, I think, about 40 services. Imagine how long you will have to spend going through individual ones to apply the conventions across the entire monorepo. So that's one thing. For the documentation, is your documentation up to date? Well, how do you know?
Because I wrote it at the same time I made the change to the code.
At the point when you made the change, every time you update it. Right. So things like, for example, we put security, so one of the requirements we had in one of the projects was to have an audit of every endpoint. What's the accessibility for that endpoint from the outside? So can a person with a certain groups access it? So you have a security audit. Now, if I were to go to every single time I change an endpoint or the security on it to the documentation updated, that would be a bit, that's a lot of work. So what we've done instead, we generated those security reports and put them as a living documentation. So every time anything changes in our code base, we will generate the living documentation. And that's all local. So you commit it with so you don't need to, like for the things that are automated, you don't have to write those things. You don't have to write, like build overviews. If you don't want to use external tools for having a better view on your GitHub, build overviews, you can generate them into READMEs. You don't want to go and update every single time on the main page when you add a new service in. Okay? Thanks a lot. Thanks a lot.